Hi folks, Thomas Henson here with thomashenson.com, and today is another episode of Deep Questions in AI. No, big data, big questions. But today is another episode where we're digging into deep learning. Like I said, I've talked about it before on here. You've seen me starting to make videos around it. I think this is a very hot topic in data science. It's one of the hottest topics. So when you think about people talking about PyTorch, Cafe, and TensorFlow, those are all deep learning pieces and frameworks that we're talking about. So I'm taking this time to share with all the data engineers out there, all the future machine learning engineers and data scientists, some concepts around deep learning so that we start to understand this. And then maybe we'll start to go through and do some tutorials and show you how, how do we use TensorFlow? What are some of the contributive abstract languages that we can use to start using deep neural networks? And so without further ado, today I'm going to talk about what neural networks are. So I'm going to give you a baseline understanding of neural networks. We're going to talk about it. And so that way you have a basic understanding. You've probably seen some of the other videos where we've talked about like unsupervised and supervised learning and some of the other like training and inference and also just questions around AI. So this is another question in that series. So I hope you'll find out more all about neural networks right after this. So welcome back. Before we get started, I want to encourage you to give me some feedback on these questions that we're going through. So if you have a question, don't hesitate to put them here in the comment section below, or go to thomashenson.com/big questions if you don't want those questions to be seen by others. I'll respond to them even if you don't want me to put it on YouTube here, but I'll respond to them and help you out as best I can. I want some real feedback around what are some of the things that you're looking to learn. So I've started doing some of these deep learning. What do you think about some of these deep learning concepts? Is it not what you're looking for? Am I not explaining it? Is there other areas or other avenues I need to go into? Let me know. That's what this community is about. That's what this channel is. It's, hey, me interacting with the community and trying to help as best I can as we all go through this journey of becoming data engineers, being better machine learning engineers, and even getting into data science. But without further ado, let's jump right into today's concept where we're going to talk about what a neural network is. So before we jump in and talk a little bit about neural networks, let's just do a little review around the difference between machine learning and deep learning, because this is a big core concept here. So machine learning, remember we've talked about it before. Machine learning is, hey, let's say we're using an image detector, so we want to be able to detect the features. Let's say that we're detecting the features of my face. So we have an image of Thomas, and we want to be able to define, is this Thomas or not Thomas? Well, some of the things that we're going to put in, we're like, hey, does he have a beard, right? So we maybe put a weight on the fact that I have a beard. What about my eyebrows? What is the space between my eyes? My nose, how are all those different features? So those are all different features. So we're going to put and assign different weights to those. Us being the data scientist, we're programming those in, or the machine learning engineer. So that's what we call machine learning. Now with deep learning, what we're going to do is we're going to take this image of Thomas, this amazingly beautiful face and awesome beard, or not. depends on who's thinking that. But we're going to take this image and we're going to feed it into our network. And that neural network's actually going to assign those weights for us. So we're going to allow for it to decide the weights and go back and forth to say, hey, maybe beard isn't such a big feature that we thought it would be, and it turns out to be that it's not a big factor, because there are things that can happen, right? I could shave the beard, there could be other images. It's just going to depend on the data that we're assigning it, and then also how it kind of goes through that process. And so that's deep learning. And so what we're talking about today, and a lot of the concepts we've talked around deep learning, are about, hey, we're allowing the neural network to assign those weights to decide, was this Thomas or not Thomas, right? Or is it a cat photo or not a cat photo? So a neural network is the part that's assigning these weights, right? And so when we talk about an artificial neural network, really what it is, I'll tell you what it's not. This is what I first thought of it. Like, I thought the neural network was more of the hardware. So kind of the first time I ever heard it, I was like, wait a minute, neural network, man, is that like 400 servers and like kind of like an HPC lab where, all these, everything's all connected because it's got to be neural, kind of like a brain. It's not really about that. It's more about the process of how the data is analyzed. So the neural network, while it is layers and while they are interconnected, it's in the software piece. So think of it as in the processing that goes through. So our image detector. So your neural network is how, it's about how to train data and mimic the way that animal brains do, specifically, maybe human brains, right? Like it's a way to train the data. And so we talked about that image detector to detect Thomas's face. What we're doing is we're allowing that neural network to take our data and for it to flow through and say, hey, did we get it right? Did we not get it right? And then if it didn't get it right, well, what improvements, what changes can we make so that we get it right, more right the next time? And so that allows you to do it a little bit different, just like human beings, right? I mean, think about it. I've got 2 small kids, so I've been going through this whole process of watching them learn and watching how they experiment and, learn things in real life. And, if you have, little brothers or sisters or, nephews or nieces, or maybe you have your own kids, you can kind of understand this too, where when you think about it, it takes a long time for a baby to learn how to do things like walk and other pieces. And so they have to experiment a lot, right? And so just walking or crawling, it's a constant experimentation and it's a trial and error, right? And, they're trying different things. They're putting everything in their mouth. It's a huge experiment, right? And that's the same kind of concept that we're trying to build here with these artificial neural networks. Is there a way for us to do a trial and error to be able to decide, whatever we're looking for? Is this image of Thomas? Is that a cat image? Are we predicting housing prices? And so it's allowing all this trial and error to happen in real time. And it's one of the reasons that GPUs are so popular with deep learning. We'll talk about that in another episode, but because you want to be able to train it and kind of go through. So think of it kind of more as a simulation. That's kind of the way I thought it. It's not a simulation, but at a high level, that's the way that it really kind of grasps for me. It's like, hey, we're going through and we're seeing, okay, can we predict that? What's the best ratio to be able to predict? Is this image of Thomas, or what is the next housing price going to be? Within knowing that's how a neural network works, there are 3 main components that I think you need to know. So you need to know that a neural network is made up of three layers. Well, first one is an input, next one is a hidden layer, and then the third is the output. And so those are really simple. They sound kind of complex, but they're not. So think of the input layer. So back to the Thomas image detector, that input layer is the data that we're sending in. So that's, we're sending in a picture of either of Thomas or not of Thomas. That's going into the input layer. The next one is that hidden layer. And so little trivia piece here. The hidden layer is actually how neural network or how deep learning gets its name, because the hidden layers can go deep. So you can add multiple layers to be able to kind of add more weights, to be able to do different things with your data, make your model more complex too. And so the hidden layer is all these different layers where we're assigning those weights, where we're doing different pieces to be able to connect that data as it's going through. So Thomas image comes in, we're going into the hidden layer. The hidden layer is assigning different weights, and then the output layer, which is that last layer, is did we get it right or not? So was it, did we detect that it was Thomas or not Thomas? If we did detect that it was Thomas, then we can kind of go back and look and see what those weights were. If it wasn't, this is where back propagation kind of comes through, and you start looking, okay, where was the problem? What were the weights assigned? What did we do different here? And like I said, it's kind of the learning process, right? And so just remember, from a neural network perspective, input, hidden, and output. Input's just our data that's coming in. Hidden layers is where our weights are being assigned through the neural network. And the output layer is, did we get it right? Did we get it wrong? And so the last piece that I think you need to know about neural networks is just think about the neurons. So when we talk about the neurons, it's getting a little bit deeper here, but we're getting a little bit deeper. It's pretty good. Didn't even plan that one. But we're talking about that hidden layer and the different pieces and the different layers that are connected. So we can know, think of it from a neuron. We can image, go all the way with our image, all the way from the input layer, all the way through the different layers that it went through in the hidden layer, and then to the output to derive, did it make the right assumption or not assumption? So that's where we start to think about these connected neurons. And if you think about it, the more layers and the more pieces of data that we have, the more complex it'll get. And you've probably seen some images out here. Here's an example of one where we really get into the differences between the way these neurons are connected and just the different data paths that all your data can go through. So that's all I have for today around deep learning. Really wanted to talk about what a neural network is and kind of explain the baseline terminology. So if you have any questions about it, throw them in the comment section here below, or just get in touch with me however you can. If you have any ideas for the show or anything like that, make sure you let me know. And until next time, I'll see you again.